I got a new monitor, so it looks a little bit different. Bear with me. AI, it's everywhere. Whether it's work or your personal life, you're hearing about it in some way, shape, or form. Most likely, if you made it to this page, it's because of work. So my goal for today is to provide a very basic overview of what AI is, how it works, along with a few considerations you should have as you're beginning your AI adoption. Now, let me preface this by saying it is a very basic overview. Now, if you want a deeper breakdown, you could go to the description below where I posted all of the resources that I leveraged to make this video, along with a few that have been included in courses that I've taken. Anyways, as I was saying, you can leverage the resources that are in the description below that I've ran across while I was taking AI courses and getting my feet wet with AI. So before anything, we have to define what AI actually is. So at a very basic level, artificial intelligence relates to technology that enables computers and machines to simulate human learning, comprehension, problem solving, decision making, creativity, and autonomy. So AI systems can understand and respond to human language and perform human tasks. Most relevant is pattern recognition. We'll get into that in a second as we talk about machine learning. So AI is not necessarily consciousness, but it is pattern recognition based on human language. So where did AI come from and why is it so popular today? So the term artificial intelligence just so happened to spawn in the 1950s. And the foundation of this comes from somebody named Alan Turing. And he conducts something called the Turing test. What is the Turing test? Basically, understanding if computers can think. Can this computer imitate a human convincingly? So in this imitation game, a human interrogator has a text conversation with both a human and a computer. So kind of like that Spider-Man meme. It's like, which one's the human, which one's the computer? Now, the computers that misled interrogators often enough, Alan basically proposed that those computers can think. So that's a very generic way of explaining how the test was conducted and the overall premise. But the idea is, can computers process just like humans? And now we get into machine learning, the subset of AI that learns from patterns within data. So essentially, machine learning intakes information, it observes the data, and then it finds the patterns, and then you get your outputs. So let's go with a very easy example. Your algorithm. Think about the things that you see on your feed when you're scrolling on social media. Think about the ads that you're getting as you're scrolling as well. Did you click on something similar to that? Did you engage with something that is similar? Whether it was on this website or another, if you allow apps to take information from other apps as well while using them. Your algorithm is a machine that is discovering patterns in your engagement and then feeding you outputs according to said pattern. So it only needs that general level data, which is your engagement, to learn via the machine and then give you outputs. So now this leads well into the next section, which is about deep learning and neural networks. I'll give a very basic definition of neural networks, then go into deep learning because they're one and the same as it pertains to machine learning and deep learning. So in basic terms, the neural network, also called artificial neural networks or simulated neural networks, are a subset of machine learning and are the backbone of deep learning algorithms. They are called neural because they mimic how neurons in the brain signal one another. So all of that data that has been inputted is being filtered by these neural networks. Now, this is guided by two fundamental pieces, which are weights and biases. So weights influence how strongly each input influences the overall decision/output. Biases are built-in values that shift that decision threshold. But the thing is, it's unpredictable, just like our human brains. Let's say, for example, somebody invites me to a party. Now, I'm in my 30s and I'm not huge on clubbing or things like that. Like, I'll do it occasionally, but when I was in college and everything, probably more viable to do it. But let's say one of the weights for going out to party is like, one, my friends are going to be there, like my really good friends. The other weight is like, is the food good or not? Okay, kind of matters, kind of doesn't. 3 is like, how late are we going to be there, and is there a plan at all? So even if like the food is not highly weighted in my decision making, my really good friends going could overtake the fact that the food is bad, location is not as ideal, and the time is super late. So on some days, I may be like, oh, I'm super down even with those variables. And then some other days I'm like, nah, I really don't want to go. It's unpredictable. But the overall concept is that those neurons are behaving in the computer just like they are in our brains as we're making decisions and giving outputs. And with that being said, now we need to talk about deep learning. So in essence, deep learning is a subset of machine learning driven by multi-layered neural networks whose design is inspired by the structure of the human brain. So deep learning refers to the depth of layers within a neural network. Deep learning requires a lot of data. I'm talking about a ton. Because as you're building into that foundational model, the main difference with deep learning is that it is going to automatically teach itself via the data that it's being fed. Machine learning is like, I'm driving the car and I want to go this way and I want to go that way. And then during the next route, it knows that I want to go in that direction. Deep learning is like, I already know how you drive. And as a matter of fact, I've leveraged your driving pattern to drive throughout the United States 3 times in a row already. Now, with that being said, deep learning requires a ton of computing power and a lot of data. Hence, all these data centers that we're seeing being built throughout the United States. And from here, this is where large language models come from. I think it's safe to assume that most people's understanding of AI and entryway into AI stems from some type of large language model system. So with that, large language models are a category of deep learning models trained on immense amounts of data, making them capable of understanding and generating natural language and other types of content to perform a wide range of tasks. LLMs are built on a type of neural network architecture called a transformer, which excels at handling sequences of words and capturing patterns in text. That last sentence is so important, and it's key to the next points that I'm going to go over. But first, let's talk about what a transformer is. The transformer model is a type of neural network architecture that excels at processing sequential data. So LLMs, or foundational models, are trained on massive data sets to make predictions and understand patterns. That is it. It's not consciousness. You're not speaking to another human on the other side, but it is a highly trained prediction and pattern recognition system. For example, so OpenAI's ChatGPT, most people don't know what GPT stands for. It is a generative pre-trained transformer. Let me say that again. Generative pre-trained transformer. So that transformer has been pre-trained to generate text based on human language via a chatbot, ChatGPT. Now, for a little bit more context, OpenAI's versions of ChatGPT 2 and ChatGPT 3 were pre-trained by Reddit. They scraped all of the publicly available Reddit data to train those foundational models, which rounds to the next point. These models recognize patterns and make predictions based on the data that they've been trained with, which is why at times AI can be wrong. So with all this being said and everything that I've mentioned throughout this video so far, as you're leveraging AI tools and LLMs in your daily work, understand that this tool is designed to give you outputs based on predictions and patterns from what it's been trained on. It just so happens to recognize your language and can efficiently develop outputs that are relevant to what you're asking very, very quickly via this very powerful system. So the output is just a recombination of things that already exist on the internet, but everything on the internet is not true. So be careful. So to wrap this up, that is a very basic overview of artificial intelligence. But overall, I hope the explanation was very simple to understand. These are the basics. I'm going to put all of my resources into the description below so that you can follow along if you want to learn more. And if I was wrong in certain areas, which I don't think I was, or if my analogies were off, let me know. Otherwise, take care, God bless, and I'll see you soon.